Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we are going to focus on the concept called message queue. So before starting with the today's session, if my voice is clear, able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Please type 1 in the chat box. Okay. If you're able to recollect what is the discussion happened in the last session, in the last session, we are trying to understand little bit detailed about named pipe. Now tell me, if one process is opening the FIFO for reading purpose, read only, can I say the open system call will block until the writing process comes? Again, when any process is trying to open for reading purpose one FIFO file, so that open system call will block until the writing process is available. Yes or no? Until the writing process comes. Yes or no? Okay. If any process is trying to open for a FIFO file for reading purpose, until and unless writing process other end is not opened, this open will block the process. Please reply yes or no. This open will block the process. This open system call will block the process. Similarly, vice versa also. If any process is opening for reading purpose, writing purpose, reading process should be there. After that, we started thinking about simplex communication. In a simplex communication, so the data is transferring from one side only. In a simplex communication, data is transferring one side. Whereas in a half duplex communication, data can be transferable two sides, but not at a time. Data can be transferable two sides, but not at a time. Now, can you tell me, in this situation, are we taken the help of one FIFO or are we taken the help of two FIFOs? In this situation, are we taken the help of one FIFO or are we taken the help of two FIFOs? In this situation, are we taken the help of one FIFO or are we taken the help of two FIFOs? We taken the help of two FIFOs. But how many processes involvement here? Two processes. How many processes involvement? Two processes. So for full duplex communication, we taken the help of parent and child and child and parent. For full duplex communication, we taken the help of four processes. Now can you tell me, parent is writing the data into F1 FIFO, first FIFO. Child is reading the data from the first FIFO. This side parent is scanning the data from the keyboard, writing into second FIFO, and this child reading from the second FIFO. So this is how we achieved full duplex communication. After that, we started thinking about one situation called deadlock situation. After that, we are trying to understand the limitations of named pipe. What are the limitations of named pipe? If writing process is writing the data, if multiple readers are there, we can't give the guarantee which reader is going to read the data. Again, if multiple processes are writing the data into, if one process is writing the data into the FIFO, if multiple processes are reading the data, we can't give the guarantee which process is going to read the data. Second is, in this, one more limitation is writing process and reading process must and should be alive at the time of at the time of communication. It's not such a mechanism where writing process can put the data, reading process can come afterwards, can read the data. These are the two drawbacks. These are the two limitations in the whatever in the last sessions we discussed it. To overcome that, today we need to discuss one more IPC mechanism. What is the name of the IPC's today's discussion? What is the name of the IPC? That is message queue. That is message queue. Today's IPC mechanism is message queue. I hope yesterday only I listed the functions involved in this IPC mechanism. Yes, I hope yesterday only I might have listed the I might have listed the functions which are involved in this IPC mechanism. What is the first function? What is the first function? MSG get. What is the second function? MSG send. What is the third function? MSG RCV. What is the fourth function? MSG-CTL, message control. These are the functions in today's discussion we are going to focus. So today's topic, we are going to divide it into three parts. Today's topic is we are going to divide it into three parts. In a part one, we are going to discuss how to create a message queue. What are the things we need to take care? In the part one, how to create message queue. What are the points we need to take care while creation? The part one, how to create a message queue. What are the points we need to take care while creation? Is that one is clear? Type 1 in the chat box. In the part 1, we are going to discuss how to create a message queue. What are the points we need to take care while creating the message queue? If this first part, what we are going to discuss, is it clear? Type 1. In a second part, how to put a message in message queue. In a second part, today, we are going to discuss how to put a message in the message queue. In a third part, how to read message in message queue. So to understand this concept little bit easily, I'm going to divide this discussion into three different parts. One is how to create a message queue and what are the points we need to take care while creating the message queue. Second is how to put a message into the message queue. Third discussion will be how to receive the message into the message queue. So what is the first now? We are going to discuss first how to create a message queue. So for this, I need to tell you, today I'm using some different laptop again. So till yesterday I used one different laptop. Today I used one different laptop. The reason is in that whatever the Ubuntu app we are using in a Windows 10, In that Ubuntu app, message queue service is disabled. Again, from the last few sessions, whatever the laptop I used it, in that laptop I used Windows 10. In the Windows 10, I used what you called Ubuntu app. In that app, message queue service is disabled. So that is the reason I taken a different laptop. In this laptop, virtual box is there. Do you know what is the meaning of virtual box? All of you might have know this virtual box. In this virtual box, Linux is installed so that all the services are enabled here. If this difference, whatever till now and now whatever I am using, if that point is clear, type C. Okay. Now observe. So what is the first task? What is the first task? The first task is, what is the first task? First task is how to create a message queue. First task is how to create a message queue. So what is the function? What is the function to create as well as open the message queue? MSG get function. All of you copy this. This is the system call. This is the system call. These are the header files we need to include. Sys types, sys IPC, sys msg.h. These are the header files we need to include. And in this msg get function, there are two arguments we need to pass. The return type is an integer. Again, in this msg get, there are two arguments we need to pass. It returns an integer. Two arguments we need to pass, and it returns an integer. What is the first argument you are observing here? What is the first argument you are observing here? What is the first argument you are observing here? Key. Now, one thing I need to tell you, whenever you are opening the file, what you should know. Again, one thing as a programmer, whenever you are opening any file, you should know the name of the file. Will you agree? Whenever you are opening any file, you should know the name of the file, because in an open system call, you need to pass the file name here. Yes or no? Whenever you are opening the file, as a programmer, you should know the name of the file. Similarly, whenever you are opening the message queue, you should know the, whenever you are opening the message queue, you should know the, whenever you are opening the message queue, you should know the, can you tell me? The key. So every message queue is recognized with, every message queue is recognized with, identified with, every message queue is identified with, can you tell me? Every message queue is identified with nodes. We should know the key when we are using message queue. This point is clear. Every message queue is identified with key. So we should know the key when we are using the message queue service. Every message queue is identified with key. If this point is clear, type 2 in the chat box. If this point is clear, type 2 in the chat box. We should know the key when we are using the message queue. Why? Because every message queue is identified with a key. Third point is using the MSG get. Using MSG get, we can create and open existing message queue. Again, using the MSG get function, what we can do? Using the MSG get function, we can create and we can open. Using the MSG get function, what we can do? We can create and as well as we can open existing message queue. Now, can you tell me what is the open system call returns? Can you tell me what is the open system call returns? Open system call returns file descriptor. Will you agree? Open system call returns a file descriptor. Yes or no? So now, what is the MSG get returns? What is the MSG get returns? MSG get returns a integer that is called message queue identifier. Again, MSG get returns message queue identifier. MSG get returns message queue identifier. MSG get returns message queue identifier. With this only, this identifier we need to use in MSG SND, MSG RCV. This identifier we need to use in message send and message receive. I need to ask you one very simple question. When you open a file, FD is equals to open data file O underscore RD only. Now tell me, once you open a file, which file you are opening here? Which file you are opening here? What is the name of the file? Which file you are opening here? Data file. Now tell me, once you open a file, you will get this reference number. This is called file descriptor. You will get a reference number that is called file descriptor. Yes, sir. Now can you tell me, once you wants to read from the file, you need to pass this as a first argument. Once you are reading from the file, you need to pass this as a first argument. Can I say the name of the file only for opening purpose? Can I say the name of the file is only for opening purpose? Once you open this file, this name, there is no use in a further process. You need to take the help of this descriptor only. You need to take the help of this descriptor only for reading and for writing and whatever it is. Similarly, whenever you create a message queue using this MSG get, you will get one identifier. So with this identifier only, we need to do with this identifier only, we need to do the transactions. Again, with this identifier only, we need to do the data transactions. This key is just for opening purpose. The key is just for opening purpose. Once you open, there is no role of this key in a further process. You need to use this identifier only. Like how the file name is there, similarly key is there. How the file name is there, similarly key is there. What are the header files? Sys types, sys IPC, sys MSG. I'll write it here. sys/IPC, sys/MSG .h. Let's start writing this. I hope already in a header file, sys types is there, sys IPC, sys MSG. This header file I taken from different folder. Sys types is already there, sys IPC and sys MSG is already there. So now I'm going to write a program p1.c hash include header.h void main int id is equals to msg get key number as 2 IPC underscore creat IPC underscore create, and while creating give the permissions. Again, in MSG get, the first argument I am passing as the key. The first argument I am passing as the key. Key I provided just for the time being, I provided as a 2. And IPC underscore create I am using, as well as permissions I given as a 0664. As I told you, MSG get function is used to create as well as opening the existing message queue. MSG get is used to create as well as opening the existing message queue. Now observe, if ID is less than 0, if ID is less than 0, then what is the meaning? We error MSG get, and no need to further proceed it, return it. Otherwise, printf ID is equals to %id /n, comma ID. Now my question is, message queue is recognized with number or name? Message queue is recognized with number or a name? Number. Now can you tell me, in this program we are trying to open or we are trying to create the message queue whose number is what? Whose number is what? In this program, I'm going to create or I'm going to open the message queue whose number is what? Whose number is what? Can I say number is 2? All of you are observing here, line numbers are not coming. Here line numbers are not coming. Just give me 1 minute of time. vi.vimrc set new cv linex underscore this vi p1.c. Now observe, in line number 6, I am informing to MSG get function. I'm informing to line number 6. I'm informing to MSG get function that if suppose there is a message queue with key number 2, open it, otherwise create it. Again, in the line number 2, I'm informing to the MSG get function that if suppose in a kernel space already with a key number 2, already with a key number 2, if message queue is there, create it. Open it. If not there, if already message queue is not there, you are informing to. If message queue is not there, informing to. Message queue is not there, informing to. Please try to respond it. Otherwise, only one-way communication will be there. If message queue is not there, I'm informing to create it. Listen, I'm informing to create it. Okay. Let me compile the code. Let me compile the code. cc, just a minute. cc p1.c. Now a command I need to show you. IPCS-q. All of you noted down the command IPCS-q. IPCS-q. Sixth point. IPCS-q is a command to display how many message queues are currently present in kernel space. Again, how many message queues are present? When you type IPCS-q, it will display how many message queues are present in a kernel space. Now can you tell me, when I type IPCS-q, how many message queues are observing currently with the key and ID, owner, permission, used bytes and messages? How many message queues you are observing? 0. No message queue is there. D9C2, observe 0. If it is might have there, the list will be here. The list will be here. B9C2, getting the point. Now can you tell me how many message queues are present in a kernel space? No message queue is there. 0 message queues are there. Now I'll run my program. ./a.out. I got ID as a 0. Now let's type the same command. Now tell me how many message queues are there. Now tell me how many message queues are there. Now tell me how many message queues are there. Will you agree? One message queue with a key number 2, ID as 0, owner, permission, used bytes. How many messages are there in this inbox? How many messages are there in this inbox? 0. With respect to linked list terminology, if I say how many nodes are there in this linked list? How many nodes are there in this linked list? How many nodes are there in this linked list? 0 nodes, means 0 messages. Actually, I need to tell you here, whatever we are discussing now, internally, it is a linked list concept only. Whatever I'm discussing now, internally, it is a linked list concept only. Internally, it is a linked list concept only. Now, can you tell me, in this program, what I'm trying to do? I'm trying to create a message queue, or I'm trying to, if message queue with this key is already there, I'm trying to open the message queue. With this key is already there, I'm trying to open the message queue. Now observe, if I change the key, let's compile the code. Let's run the code. ID is 1. Now observe, IPCS-Q. Can you tell me how many message queues are present in a kernel space now? Can you guess? How many message queues are present? 2 message queues. One is with a key number 2, another one is with a key number 3. Now tell me, can I say here 2 post boxes are there? In a general term, if you see, there are 2 post boxes are there. With respect to linked list terminology, if you think, there are 2 linked lists are there. But first linked list, second linked list, there is no nodes. There is no messages. IPCS -Q. If you want to remove the message queue, we need to use IPCRM command. 7th point. If you want to remove the message queue, we need to use, if we want to remove the message queue, we need to use IPCRM command. If we want to remove the message queue, we need to use IPCRM command. If you want to remove the existing message queue, we need to use the IPCRM command. I'll show you how to use this. IPCRM -Q. Now observe, IPCRM -Q2. Well, if you're observing, we removed the message queue whose key is 2. So IPCRM -Q, you need to provide the key. IPCRM -q, you need to provide the ID. IPCRM -Q, for example, IPCRM -Q, you need to provide a key. What is the meaning of dollar symbol here? IPCRM -q, you need to provide an ID. Can you tell me what is the meaning of dollar? That is nothing but a command prompt. Just to indicate that is a command prompt. BE9C2, is it clear? That just indicates that is a command prompt. Is it clear? So you can remove the message queue by using the key number. You can remove the message queue by using the ID. Again, you can remove the message queue by using the key number. You can remove the message queue by using the ID. You can remove the message queue by using the key number. You can remove the message queue by using the ID. Is this point is clear? Type C in the chat box. Now tell me, I removed the message queue using the ID or key number here, capital Q. Capital Q. I removed the message queue using the ID or using the key number. Key number. If I write IPCRM hyphen Q. Now I need to provide ID. IPCRM small q, I need to provide the ID here. Getting the point? I need to provide the ID there. Now let's observe when I press an enter button now. When I press an enter button now observe. See, there is no messages in the message queue now. There is no messages in the message queue now. There is no messages in the message queue now. There is no message queues now. Sorry. There is no message queues currently. And if you're observing, there is no message queues currently. Now, one logical question I need to ask you, very logical, very simple question, very logical question. Suppose there are two message queues. One key number is 2, ID is something. Another key number is 3, ID is something. Again, there are two message queues. One message queue key number is 2, ID is something. Another message queue key number is 3, ID is something. Suppose ID is 1111, ID is 2222. Now tell me, if one process is putting the message into this message queue, if another process is reading from this message queue, they can do the data transfer, they can communicate between each other. If one process is putting the data into first message queue, if another process is waiting the data from the second message queue, is the data transferring and receiving happens or not? Will the data transfer and receiving happens or not? Suppose one process is putting the data into the message queue whose key is, can you tell me? Writing process is writing the data into the message queue whose key is 2. Reading process is waiting for the data whose key is 3. Can they communicate between each other? Answer is no. BE 9M8. Answer is no. So what is the conclusion here? What is the point here? Can I say, when you are establishing a communication between the two processes using the message queue, so both should open the same message queue. Both should open the same message queue. BE 9M8. Is it clear? This is one of the important points we need to take care. Now tell me, in a last IPC mechanism, if one process wants to write hello world, send hello world to another process using the FIFO. Suppose this process is putting the data into F1 FIFO, this process is waiting from F2 FIFO. Is whatever this process sent, will it receive? Again, in the last IPC mechanism, P1 process is putting the data into F1 FIFO, P2 process is waiting from F2 FIFO. Is the P1 process, whatever it is putting, P2 can receive it or not? P2 can receive it or not? When P1 is writing the data into F1 FIFO, P2 is waiting from the F2 FIFO. P2 will receive it or not? I'm waiting for the answer. P2 will receive it or not? P1 process is putting the data into F1 FIFO. P2 process is reading the data from F2 FIFO. Will they communicate or not? Will they communicate or not? Answer is no. Can I say both must and should? Transmitter and receiver must and should deal with the same FIFO. Then only the communication happens. Transmitter and receiver must and should deal with the same FIFO. Then only the communication happens. Here also the same thing. If P1 process is writing the data into whose message queue key number is 2, P2 process is waiting from the message queue whose key number is 3. Can I say they cannot communicate between each other? Can I say they cannot communicate between each other? They cannot communicate between each other. So in this IPC mechanism, if two processes wants to communicate between each other with the help of a message queue, both must and should open the message queue with the same key. Both must and should open, transmitter and receiver, both must and should open a message queue with the same key. Then only the transaction happens. Then only the transaction happens. Otherwise, then only the transactions happens. Otherwise, there is no transaction. Then only the transaction happens. Otherwise, there is no transaction. If this is clear, type C in the chat box. So this is the part 1. As I told you today, I'm going to divide into 3 parts. In a part 1, what I told? In a part 1, I told you to show how to, I told you I am going to discuss how to create and open the message queue. Now tell me, what are the important notes here? We should know the key number when we are using the message queue. We should know the key number when we are using the message queue. First point. Second point is every message queue is identified with a key. Third point is using MSG get we can create as well as we can open the existing message queue. MSG get function returns the message queue identifier. This identifier is used to in MSG send and MSG receive. IPCS-Q is the command. IPCS-Q is command to display how many message queues are currently available in a kernel space. If we want to remove the message queue, we need to use IPCRM command. If you use IPCRM-Q, you need to provide a key. If you use IPCRM small q, you need to provide ID. Is this important? Points are clear? This is just opening purpose. This is whatever till now the discussion happened from the last half an hour. Just creating or opening the existing message queue. So what is the next step? What is the next discussion? Next discussion is how to send message into message queue. Second part, what are the points we need to take care when we want to send a message? What are the points we need to take care when we want to send a message into the message queue? Which function I need to use to send a message into the message queue? Which function? We need to use MSG SND to send message into message queue. We need to use MSG send to send a message into message queue. All of you copy these arguments, MSG send and MSG RCV. All of you copy these two arguments clearly, MSG send and MSG RCV. Just all of you copy these arguments, MSG send and MSG RCV. MSG send 1, 2, 3, 4 arguments. MSG send 4 arguments. 1, 2, 3, 4 arguments. Whereas MSG receive 1, 2, 3, 4, 5 arguments. Okay. In MSG send, we need to pass 4 arguments. In MSG send, we need to pass 4 arguments. And in MSG RCV, there are 5 arguments. If this copied it, please type C in the chat box. MSG send, you need to pass 4 arguments. MSG RCV, you need to pass 5 arguments. So first our focus will be on, can you tell me first our focus will be on MSG send? Will you agree? First our discussion will be on MSG send. First our discussion will be MSG send. Now what is the first argument of MSG send? What is this first argument of this MSG send? Answer is MSQ ID. From where you will get this ID? Can I say return value of MSG get function? Again, the first argument of MSG send is very important argument, that is MSQ ID. That is MSQ ID. That is nothing but the first argument of the return type of MSG get function. Second argument is what? Second argument is what? Can I say second argument is the address. Star means you need to provide an address. Will you agree? Star means you need to provide an address. What is that address? We need to provide some const void star. We'll see that. Third argument is the size. Fourth argument is the flags. Third argument is the size. Fourth argument is the flags. Again, the first argument is the ID. Second argument is the address. Third argument is the size. Fourth argument is the flags. One important point now I need to tell you. I'll show you this man page here. I'll show you this. All of you noted down this. The MSGP argument is a pointer to the caller defined structure of the following general form. MSGP argument is a pointer. MSGP argument is a pointer to a caller defined structure. MSGP argument is a pointer to a caller defined structure of the following general form. MSGP argument is a pointer to A caller defined structure means what? Caller defined means. So what is the important point here is whenever we want to send a message into the message queue, we should not simply the message. We should not send simply message. We need to design our own structure. I'll write it here. I'll write that point here. Second point, when we want to send message into message queue, we need to create a structure. So the structure should be in this form only. Whenever we want to send a message into the message queue, we need to create a structure. The structure should be in this. First argument will be message type. It must and should be greater than 0. First argument should be message type. It must and should be greater than 0. Second argument is what message we want to send. Second argument is what message we want to send. Now I need to tell you, in this message queue IPC, every message is recognized with type, message type. In this message queue IPC, every message is recognized with one type that is called as a message type. This message type is used in the receiver section. Again, now every message in every message queue, every message should have one type. Now tell me, from the last two IPCs, pipe and named pipe, just we simply sent a message, only the message hello, hi, or whatever it is. But every message is not having any type there. Every message is not having any type there. Will you agree? Every message is not having any type. But here, every message should have one type. But here, every message should have one type. I'll show you. That will be more clear. I'll show you. That will be more clear. So what is our first responsibility? I need to declare a structure. Struct MSG. What is the name of the structure? MSG buff. Is it? In this structure, first member should be long M type. Second member should be long M type, must be greater than 0. This must and should be greater than 0. First member is a long M type, that must and should be greater than 0. You may get a doubt. Sir, can we exchange this order? Can we change this order? First will be our data, second will be long M type. Answer is no. First member must and should be this, and second member is as you wish. Suppose you want to send one integer array via message queue. Suppose you want to send one integer array via message queue. What will be the second member? Suppose you want to send one integer array using a message queue to somebody else. So what will be the second member? Suppose you want to send an integer array to the other process. What will be the second member? Second member is integer array. Suppose you want to send a student database structure to another process. Suppose you want to send a student database structure to another process. Then what will be the second member? Suppose you want to send student database structure to another process. What will be the second member? Second member is struct st s1. Second member is struct st s1. So whenever you are transferring the data using the message queue, whenever you are dealing with a message queue, whenever you want to send a message into the message queue, the message should have one format. You should not send as it is you want. The message must and should have one standard format. What is that? That format is you need to declare a structure. That structure contains two members. The first member must and should be that contains the two members. The first member must and should be, what is the first member? What is the first member? The first member must and should be, the first member must and should be long integer message type. Second is your message, whatever you want to transfer it. Second is whatever the message you want to transfer, that is the second member. Is this point is clear? Are you able to differentiate this IPC from the last two sessions, whatever the IPC we discussed it? Are you able to differentiate the IPC, whatever we are discussing now, from the last two sessions, whatever we discussed? From the last two sessions, 2-3 sessions, whatever the IPC we discussed, in that IPC, there is no message type, only message. There is no specific type to that message. But in this IPC, whenever you want to transfer a message, you need to follow some protocol, you need to follow some procedure. You should not simply transfer the message. First is you need to declare a structure. First is you need to declare a structure. That structure should contain two members, and first member must and should be, that structure should contain two members. First member must and should be M type, long integer, message type. Second member must and second member is your data, whatever the data you want to transfer. Which type of data you want to transfer, that will be the second member. If you want to transfer a string, second member will be character array. If you want to transfer one integer, second member will be one integer. If you want to transfer one structure, student database structure, the second member should be a structure variable. I hope it is clear. So this is the standard format. This is the standard format in this IPC. If this point is clear, type C in the chat box. If this point is clear, type C in the chat box. Okay. Now what I'm going to do is I'm going to do a small change in this code. So what is the meaning of this? Int argc character double star argv. Can I say I am taking the input from the load time command line? Int argc character double star argv. Will you agree? We are taking the input from the load time. So now observe, if argc not equals to 3, if argc not equals to 3, I need to display the usage message. Printf usage dot slash snd message type and message. dot slash snd message type and message. For example, enter example dot slash snd to help dot slash snd to hello. What is that to there? What is that to there? Can I say the to is nothing but the type of the message? Okay. The to is nothing but type of the message. Now what is the next step is? What is the next step is? We need to create MSG buff. Now can you tell me what is the V? V is a variable of struct MSG buff. Will you agree? V is a variable of struct MSG buff. So we need to fill that. What is my intention is? What is my intention here is from the command line, I'm going to take the two inputs. One is the message type and another one is the message. From the command line, I'm going to take the two inputs here. One is a message type and another one is a message type and another one I'm going to take the message. Those what I'm going to do is, those I'm going to fill in the structure. Those two informations, suppose this is the thing, I'm going to fill into this structure. The structure, I'm going to send it into the message queue. I'm going to send into the message queue. All of you are getting the procedure how to deal with the message queues. All of you are getting the procedure how to deal with the message queues. So you need to declare one structure. In that structure, the first member will be the M type and second member will be, the first member will be M type and the second member will be, first member will be M type and second member will be message. Correct. Second member will be the message. Now observe. V dot MSG TYP is equals to A to I ARGV of 1. Now can you tell me why I am using A to I? Why I am using A to I? V dot MSG TYP, TYP, right? TYPE or TYP? MSG TYP M type. Why I am using A to I function? Why I am using A to I function? Because yes, whatever we pass through command line, all those are treated as a strings. Whatever we pass through command line, all those are treated as a strings. So we converted into that. After that, strcpy v dot data comma argv of 2 means, can I say from the command line, whatever the inputs I am taking here, those inputs I am putting into the structure V. From the command line, whatever the data, whatever we are taking the inputs, two inputs we required. One input is type of the message. One input is type of the message and another input is the message. Again, we required two inputs. One input is type of the message. One input is type of the message and another input is message. So whatever we are taking from the command line, those we are inserting, we are placing, we are putting into this structure. Whatever we are taking from the command line, we are placing, we are filling into this packet. Huh? Whatever we are taking from the command line, we are putting into this packet. Now, what is the next step? Can you tell me? After filling this envelope, after filling this packet, what is the next step? After filling this envelope, what is the next step? After filling this envelope, after filling this packet, what is the next step? Next step is we need to send. Next step is we need to send into the message queue. We need to put it into the post box. Will you agree? We need to put it into the post box. Which function? MSG SND. What is the first argument? ID. Second argument. What is the second argument? Address of V. Third argument. strlen of V dot data plus 1. Fourth argument is a flag. P error. P error. So now here I need to tell you, first argument is the ID from which message queue. Now tell me my message queue is recognized with what key? Tell me my message queue is recognized with what key? My message queue is recognized with what key? Key number 3. Will you agree? My message queue is recognized with key number 3. And what message I am sending? What is the message I am sending? This is the message. What is the type of the message I placed? What is the type of the message I placed? What is the type of the message I placed there? Can I say type of the message is to? Type of the message is to. So let me compile the code. What is the executable file name I need to create? -o snd. M type, is it? So long M type. So here M type. MSG buff doesn't have the member as a data. Instead of data, I written S, right? Here instead of data, I written as a S. So you can change it as a data. Now observe, sending program is ready now. Can I say sender is ready now? Now observe, IPCS-Q. How many message queues are there now? Tell me. IPCS-Q. How many message queues are there? 0 message queues. Now observe, /snd to ABCD. Now observe, /snd. So can I say one message is there? Will you agree here? One message is there. One message is there. Same thing if I parallelly if I represent. Same thing parallelly if I represent. Same thing if I represent parallelly. Now tell me, whatever the message queue I created, What is the key number? But whatever the message queue I created or opened, what is the key? Key as 3. Some ID, you will get it. Now tell me, how many messages I transferred into the message queue? How many messages I kept into the message queue? How many messages I kept into the message queue? One message. What is the type of the message? What is the type of the message? 2. What is the message? Hello. Type of the message is 2 and message is hello. Now observe /snd, message type is 5, message is AAA. Now can you guess how many messages are there now? Can you guess how many messages are there now? How many messages are there now? Can I say 2 messages in this linked list? 2 nodes are there in this linked list. 2 nodes are there in this linked list. Now tell me, what is the second node? What is the type? What is the type? What is a message type? What is a message type? What is a message type? 5. What is a message? What is a message type? 5. What is a message? Can I say it is like a linked list only internally? Now one more. /snd to MNOP. One more message I am sending. One more message I am sending. One more message I am sending. Type is 2 and message is MNOP. Is it? Type is 2, message is MNOP. Let's send one more message. Let's send one more message. Type is 4, HAI. One more message let's send. Type is 4, message is hi. One more message let's send. Type is 6, BY. So observe here, one more message with 4 and hi. One more message with the type is 6 and y. Now can you tell me overall how many messages are there in this queue? 1, 2, 3, 4, 5 messages. Overall 5 messages are there in this queue. Overall 5 messages are there in this queue. How can you check? How can you check? Will you agree? There are 5 messages are there. Now can you tell me this message queue is recognized with what? This message queue is recognized with what? Total message queue is recognized with what? Total message queue is recognized with what? Can I say key? What is the key I used here? What is the key I used here? Key number I used here. Can I say key number is 3? How many messages are there in this queue currently? How many messages are there in this queue currently? How many messages are there in this queue currently? Can I say currently 5 messages? In this queue currently 5 messages. What is the first message? What is the first message? Hello. What is the type of the first message? What is the type of the first message? 2. What is the second message? What is the second message? A. What is the type of the second message? What is the type of the second message? 5. What is the third message? What is the third message in this inbox? What is the third message? MNOP. What is the type of the third message? What is the type of the third message? What is the type of the third message? 2. What is the fourth message? What is the fourth message? Hi. What is the type of the fourth message? What is the type of the fourth message? What is the fifth message? What is the fifth message? Bye. What is the type of the fifth message? What is the type of the fifth message? 6. Is that is clear? Now can I say overall 1, 2, 3, 4, 5 messages are there and they kept in a kernel space. Now will you agree receiver program we have not yet written? Will you agree now receiver program we have not yet written? Transmitter is transmitted the data, it left. Transmitter program is transmitted the data, it left. Transmitter program is transmitted, kept the data into this inbox, it left. Now receiver can come afterwards. Receiver can come afterwards, can receive the data. All of you are getting the point? The transmitter is transmitted the data, it left. Receiver can come afterwards, can receive it. Now one point is, when receiver wants to receive the data, it must and should know this password, this number, this address. Then only the receiver can receive it, otherwise not. Again, in the receiver section, if receiver wants to receive one message, now suppose if I write /RCV 2. So now tell me, is there any message with a type 2 here? Is there any message with a type 2? Is there any message with a type 2? Yes. How many messages are there with a type 2? How many messages are there with this type 2? 2 messages. Can you guess which message the kernel will give us? Q. Message Q. Can you guess which message the kernel will give us? Hello or MNOP? Can you tell me which message the kernel will give us? Hello or MNOP? Hello. Why hello? Can you tell me why hello? Because Q follows first in, first out. Will you agree? Once the kernel given this message to this process, that message is deleted. Once the kernel gives that message to the process, kernel will delete that node. I hope all of you know how to delete a node in a single linked list. Is it? I hope all of you know how to delete a node in a single linked list. Once the kernel given that message to us, the kernel will delete the message. Now tell me, when I write /RCV6, this is the program we are going to implement now, receiver program. /RCV6. Can you tell me which message the kernel will give us? Can you tell me which message the kernel will give us? Can I say kernel will give us this message? Once the kernel given this message to this process, this message is going to be deleted from the queue. Once the message is given kernel to us, the message is going to be deleted from the queue. If the number is not there, suppose /RCV8, so this process will wait. That is also I'm going to show you practically in the receiver section. That is also we are going to discuss in the receiver section. Is it clear? That is also I'm going to discuss in the receiver section, receiver program. Now, will you agree in this IPC mechanism, every message should have one type. In this IPC mechanism, every message should have one type, message type. In this IPC mechanism, every message should have one type. Now what I'll do is, I'll open this program. If any doubt in this program, please let me know. Sending program. In this program, any doubt in any line number, let me know. Especially in a sending part. Especially in a sending part. P.M type, A to I, argv of 1, strcpy. I'm filling the structure and I'm sending it. In MSG SND, what is the first argument? In MSG SND, what is the first argument? In MSG SND, what is the first argument? ID. Second argument is address of the structure variable. Third argument is the size of the data which we are sending. The size of the data which we are sending. Fourth argument is flags. Don't worry about the flags right now. I'm putting the flags as a 0. Fourth argument is the flags. Don't worry about the flags right now. I'm putting 0. I'm putting 0 into that flag parameter. If sending program is okay, type S in the chat box so that we'll move to the receiver program. If sending program is okay, so that we'll move to the receiver program. Okay, so now the time is 8:53. Take a 7 minutes break. Receiver program will discuss at 9 o'clock. Is it clear? Now the time is 8:53. Let's take a break of 7 minutes. So after that we'll come and we'll discuss the receiver program. I'm not going to close the meeting. In the same meeting, just I'm going to mute myself. Is it clear? Just I'm going to mute myself. Okay. Now the time is 9 o'clock. So whatever the break I given, the time is done. So till now, two parts we discussed it. Part number one, till now we discussed two parts. The first part, how to create a message queue, we discussed it. In a second part, how to send a message queue. So how to send message into message queue. We discussed it. Will you agree? What is the third we need to discuss now? What is the third we need to discuss now? Third, we need to discuss how to receive the message. Third, we need to discuss how to receive the message. For that, which function we need to use? For that, which function we need to use? For that, which function we need to use? RCV function. P1.c, P2.c. In this P2.c, I'm going to write the program. This is the demo program to show how to receive message from message queue. So this is the demo program where how to receive the message from the message. So here I'm expecting two arguments. One is /RCV and M type. Which message you want? Example /RCV. Now tell me, if I execute this program, executable file like this, which message the kernel should give? For example, which message the kernel should give us? Will you agree? The message whose message type is to, the kernel should give us. The message whose message type is to, the kernel should give us. If there is no message with a type 2, then MSG RCV will block. Again, if there is no message with message type 2, then MSG RCV will block. If there is no message with message type 2, if there is no message with message type 2, MSG RCV will block. Is it clear? So up to half of the portion is same, only this portion we need to. Now here MSG RCV, anybody is remember the arguments? Alt Control T. One more terminal I'm opening just for our reference purpose. CD Linux_89 man MSG RCV. What is the first argument of MSG RCV? First argument is the ID. What is the second argument? What is the second argument? Address. Address of a structure variable. What is the third argument? What is the third argument? Size. Third argument is the size. Size of V. Fourth argument is A to I ARGV of 1. This is very important argument. Fourth argument. This is very important argument. Fourth argument. Which type of message you want? Now can I say that message I am taking from the command line? Which type of message? That type I am taking from the command line that I need to pass. Again A to I. Why? Because from the command line which I take, that is a string. Why? Because from the command line which I take, that is a string. From the command line, whatever I taken, that is a string. That is I'm using here to I. So /RCV 3. Can I say 3 we are passing here? Will you agree we are passing 3 there? And where the kernel will fill? Kernel will fill that message into this address. Now, can you tell me who is maintaining all these things? Can you tell me who is maintaining all these things, these messages? Kernel will maintain. Where? Who will maintain this? Obviously, kernel will maintain. Where it will maintain? In a kernel space, right? Where it will maintain? In a kernel space. As I told you, this MSG RCV will block. Again, if you want, we can write it. Printf before MSG RCV escape YY P printf after MSG RCV. Now tell me, before is printed, after is not printed. What is the meaning? Tell me, before is printed, after is not printed. What is the meaning? Before is printed, after is not printed. What is the meaning? Can I say MSG RCV is blocking? Printf data is equals to percentile s slash m v dot data. Now can I say kernel will fill the message into this address? Will you agree? The kernel will fill the message into this location. Kernel will fill the message into that location. Let me compile the code. cc p2.c -o rcv. Receiver program is ready. Just for our reference purpose, I'll open one more terminal. Just for our reference purpose, I'll open multiple terminals. Okay. So cd linux _89. Now here also cd linux _89. Just give me some time so that I'll arrange it properly so that you can feel the output clearly. Please give me some time so that I'll adjust the things. So how many windows, how many terminals you are observing here? How many terminals you are observing here? Will you agree? You are observing 3 terminals. I hope one more terminal is also there. One more terminal is also there. Now it is 4 terminals. Four terminals, 4 processes I'm going to show you. 4 terminals, 4 processes. Now observe /RCV 3. Now why this is blocked before MSG RCV? Can you tell me when I write /RCV 3, why that is blocked? Why this process gets blocked? /RCV 3, why this process gets blocked? Can I say in the current message queue, there is no message with 3? Current message queue, there is no message with a 3. Will you agree? That is the reason this process gets blocked. I'll write 1, 2, 3, 4. 4 windows are there. In a first window, one process is waiting for the message with a type. In a first window, one process is waiting for the message with a type. Please answer it. In a first window, one process is waiting for the message with a type. In a first window, a process is waiting for the message with a type 3. In a second window, 2. Is there any message with a type 2? Is there any message with a type 2? Yes. Can I say ABCD is received? All of you are observing that ABCD is messaged, received it. Can I say kernel is given this message? Is it ABCD or what? What is the message we received? We should receive what? We should receive hello, right? Maybe. Let's see once again. Maybe previously I might have sent. Now MNOP. Now let's see. I'm deleted those two. Now let's see /snd with the 2 I'm sending. Now tell me, when I send the message with a type 2, who received it? When I send a message with a type 2, who received it? The process which is waiting for the 2, that is received it. The one process is still waiting for the message 3. One process is still waiting for the message 3. Now observe, in this, here in a third window, /RCV 5. 5 is AAA, is it? 5 means AAA. Yes, the kernel is given this message. 2 already gone. This may be not hello. I might have written ABCD. Maybe the wrong. Okay. Now you tell me. Now you tell me how many processes are waiting for the data now. Can you tell me how many processes are waiting for the data? How many processes are waiting for the data? How many processes are waiting for the data? Can I say 3 processes? 3 processes are waiting for the data. In a terminal 1, the process is waiting for the data whose message type is. In a terminal 1, the process is waiting for the data whose message type is. In a terminal 1, the process is waiting for the data whose message type is 3. In a terminal 2, the process is waiting for the data whose message type is. In terminal 2, the process is waiting for the data whose message type is 2. In a terminal 4, a process is waiting for the data whose message type is. In a terminal 4, a process is waiting for the data whose message type is 5. Now observe, in a terminal 3, /send 5, who will receive? Terminal 1 process or terminal 2 process or terminal 4 process? Who will receive now? Terminal 1 process or terminal 2 process or terminal 4 process? Terminal 4 process. Observe. Hmm? Terminal 4 process is received there. Now you tell me dot slash snd 3. Now who will receive? 3. Who will receive? Terminal 1 process. Hmm? Now dot slash snd 2. I hope with this you got something about receiver section. I hope with this you got something about receiver section. Again, some of you may get a doubt, sir. If two processes are waiting for the same, then what happens? Let's experiment that. Dot slash RCV 2 dot slash RCV 2. Now, can I say in a terminal 1, one process is waiting for the message 2, message type 2. In a terminal 2, also one process is waiting for message type 2. Who received? Who received first? Now observe. Now once again send it. Who will receive? Now can you guess what happens here? If two processes are waiting for the same message, so which process will receive? First come first serve. First come first serve. First come first serve. Okay. Now I hope with this, in a today's session, you might have got how to create a message queue, how to send a message into the message queue, how to receive the message from the message queue. In a tomorrow session, many more properties of message queues we need to discuss it. Is it clear? In a tomorrow session, many more properties of message queue we need to discuss it. Is that clear? So I'm going to wind up the today's session. Tomorrow, many more properties of message queue we'll discuss it. It's clear? Thank you very much. I'm going to wind up the session.